Chapter 5, Unit 4. Using z-scores to standardize a population distribution. So we can standardize an entire distribution of raw scores into a distribution of z-scores. So look at the graph on the left. You'll see it has raw scores with a mean of 100 and a standard deviation of 10. And then we transform them into z-scores. And z-scores always have a mean of 0 and a standard deviation of 1. The shape will always remain the same. If raw scores are positively skewed, then a z-score distribution will also be positively skewed. If raw scores form a normal distribution, then the z-scores will form a normal distribution. The mean of the z-score distribution will always be 0. The standard deviation of a z-score distribution will always be 1. So let's use z-scores to standardize a sample distribution. Again, it looks just like the population distribution. You standardize the entire distribution of raw scores into z-scores. The shape remains the same. Raw scores are positively skewed, then z-score distribution will also be positively skewed. If raw scores form a normal distribution, then z-scores will form a normal distribution. The sample of z-scores will have a mean of m sub z equal to 0. The sample of z-scores will have a standard deviation of s sub z equal to 0. And the new set of z-scores is still considered to be a sample, and sample equations must still be used. So here's an example. Find z-scores for the following distribution of sample scores: 0, 2, 4, 4, and 5. Step 1, find the mean and standard deviation, just like we always do. Find the sum of squares. I found it to be 16. Find variance. I found variance equal to 4. Find standard deviation. I found that equal to 2. Step 2, we make a new column called x minus m, which are the deviation scores. So we subtract the mean from each score. And the mean was 3 for this sample. So we subtract 3 from each original x value to get all the numbers in the x minus m column. Finally, we make a z column. The formula is x minus m over s. So we already have an x minus m column, so we just divide it by s. And you'll notice in the equations above we found s to be 2. So we're going to take the value in the x minus m column and divide them by 2 to get the z-scores for each original score. Notice that if you sum up the z column, it always equals 0. And this would give you a mean of 0 as well, which is always true for z-score distribution. All right, continuing with the same example, let's say we took the original x scores and we plotted them. So the raw scores are on the top. We have a 0, a 2, a 4, a 4, and a 5. Well, what happens if we plot the z-scores? Notice the shape is exactly the same. But notice the mean of the original distribution was 3 with a standard deviation of 2. But notice the mean of the new distribution of z-scores has a mean of 0 with a standard deviation of 1. Again, this will happen every time you transform scores into a z distribution. So let's talk about standardized distributions. A standardized distribution is one whose scores have been transformed to create predetermined values for the mean and standard deviation. This makes it possible to compare scores from totally different distributions. And we're talking about a z-score distribution right now. Later you'll learn about other distributions like a t-test distribution. Okay, so here's an example comparing two different tests from two different distributions. Dave took a biology test and made a 56. The biology test had a mean of 48 with a standard deviation of 4. Then he took a psychology test and he made a 60. The psychology test had a mean of 50 and a standard deviation of 10. On which test did Dave do better? Step 1, we're going to create a table using bio scores, z-scores, and psych scores. I usually just put z in the middle, but you could put it on the top if you liked. And draw your curve. Draw your first line at x equals 56 for the bio scores. So that would be the green line here. Looking at the bio row, find 56 and draw a line. And the next one, you're going to draw a line of x equals 60 for the psych scores. Well, 60 is on the psych row, so draw an orange line there, or whatever color you like. Or you could make a dashed line for the second one. So We have to find the z-scores for each one. Well, we can just read them right off the table. For the bio row, a score of 56 corresponds to z equals plus 2. For the psych row, a score of 60 corresponds to a z of plus 1. Now let's verify these using our z-score equation. So for bio, z would equal 8 divided by 4, which is 2. For psych, z would equal 10 divided by 10, which would give you 1. They match. So which score did Dave do better on? He did better on the bio test. The higher the z-score, the higher the percentage. Remember that the normal curve corresponds to exactly 0 to 100% on any given distribution, with 0% being on the left and 100% being on the far right. Learning check problem 1. Pause the video, see if you could solve the problem. A population with a mean of 90 and a standard deviation is transformed into z-scores. After the transformation, what is the mean for the population of z-scores? Well, there's really no work here. The population of z-scores always has a mean of 0. All right, problem 2. Pause the video. A sample with a mean of 70 and a standard deviation of 15 is transformed into z-scores. After the transformation, what is the standard deviation for the sample of z-scores? Well, a distribution of z-scores always has a standard deviation of 1. All right, learning check problem 3. Which of the following is an advantage of transforming x values into z-scores? It's so that dissimilar distributions can be compared. Learning check problem 4. Sarah took a math test and made a 45. The math test had a mean of 30 and a standard deviation of 5. Then she took a Spanish test and made a 65, but the Spanish test had a mean of 60 and a standard deviation of 6. On which test did Sarah do better? Step 1, create the table using math, z-scores, and Spanish scores. Step 2, draw a line at x equals 45 for math and x equals 65 for Spanish. Notice 65 is not on the table, on the row for Spanish, but you could estimate where it would be. Finally, you need to find the z-scores. Well, you can read off the table that x equals 45 for math is a z-score of 3, and x equals 65 is going to be a z-score somewhere between 0 and 1. So we can verify this using the z-score equation, and for math, we get z is equal to 3. For Spanish, when you put the numbers in, you get 5 over 6, which is a plus 0.83. So that also works out somewhere between 0 and 1. So which one did she do better on? Sarah did better on the math test. The higher the z-score, the higher the percentage. And a z-score of plus 3 is like 99.9% she made on that test. She did really well.